so again, our title says how many 1/3 pieces are in one whole. Go ahead and write your title down, please. John, I need you to move faster. I know, I just need it to be faster. Thank you. I'm not being mean. I'm telling you, I just need you to move faster. Thank you. All right, we got a couple of different ways we can model this. If I am trying to figure out how many 1/3 pieces are in one whole, could I start with one whole bar? Sure. Let's go ahead and draw one bar. For those of you who are not used to Ms. Miller, I'm not a big fan of the circle model. Circle models will work. It's fine. But I am not a fan because they're very hard to make those equal sized pieces. So I'm a big fan of a bar. I have one whole bar. Yes? Well, that's not going to tell me how many holes to draw. So far, I just got one hole. Sure, we're just not there yet. We got one whole bar. So far, so good? How many 1/3 pieces would fit in there? John, is there a reason you don't even have the title down? Mackenzie, how many 1/3 pieces would fit in there? How do you know? Yeah, that denominator tells us that. Split it into thirds. This piece is worth 1/3. This piece is worth 1/3. This piece is worth 1/3. How many 1/3 pieces is that? This is not a trick question. I should see like every person's hand. How many 1/3 pieces are in one whole? Bryson? 3. 3. 3 1/3 pieces. There's another way to write that. How else could I write that? That's not incorrect. 3 1/3 pieces is correct. We counted them. But there's another way that I can show that. How else do I write that? Wyatt? 3/3. AKA 3/3. John, we're writing.
I am trying to put my thing back on.
Can we do it quickly, please? Because we're moving on.
It's rolling on one.
We know another model we can use. It's the one we used this morning for number talk. Is our number line. Fractions live on a number line. I've got my one whole number. 0 to 1 is a distance of 1. Right? Taking it way back to kindergarten. 0 to 1. 1. Easy peasy. How many 1/3 pieces are in that? Not a trick question. How many 1/3 pieces are on that? Kinsey? 3. Split it into thirds. This piece is worth 1/3. This piece is worth 1/3. This piece is worth 1/3. So far, so good, yes? Nothing complicated, nothing really new happening.
Keep going.
No. Alright, subtitle. Very similar to our original title. How many 1/3 pieces are in 2 holes? How many 1/3 pieces are in 2 holes? Write that subtitle, please. How many 1/3 pieces are in 2 holes? 2 whole candy bars. 2 whole cupcakes. 2 whole anything. To figure that out, we need 2 wholes. So how many bars am I going to draw?
2.
2. 1 whole Kit Kat for Miss Miller. 2 whole Kit Kats for Miss Miller. Huh? Oh, sorry. 1 whole Kit Kat for Miss Miller. 1 whole Kit Kat for Baby Mac. Baby Macklin, not child Macklin. Could be tricky. How would I do that? How many 1/3 pieces are there? Break up your holes. In your notebook, break up your holes. I want 1/3 pieces. Raise your hand when you figure out how many 1/3 pieces are in 2 holes. How many 1/3 pieces are in 2 holes? You go?
Oh, 6.
6? Did we get 6?
Yeah.
Yeah? I'm gonna break my first one. That's 1/3. That's 1/3. That's 1/3. I'm gonna do my second one. That's 1/3. That's 1/3. That's 1/3. Let's count them. Ready?
1/3, 2/3, 3/3, 4/3, 5/3,
6/3. That's what that number looks like. AKA 6 1/3 pieces. If I'm writing, you're writing. I already passed 3rd grade once. 6/3. How would that look on a number line? Am I going 0 to 1?
No.
I'm going 0 to 2. 2 whole numbers. 1, 2. I find it very helpful to also figure out where 1 is going to go. This is not tricky. If my number line is 0 to 2, where does 1 go? Kick way back to like 1st grade land. Where does 1 go? John?
The middle.
The middle.
Okay.
Oh, it's like an exclamation point. 1.
No, it's like a king.
How do I do that? What do I do now? Now it gets kind of tricky. Ooh, what do I do now? Kaden?
You can split each section like 0 to 1 and 1 to 2.
Yes! I'm splitting up each whole. 0 to 1, right here, is 1 whole. So I'm going to split it into my thirds. 1 to 2 is still 1 whole. It's just a different whole. So I'm still going to split it into thirds. So far, so good. Evelyn?
I'm learning this song again.
Fantastic. Love that. It's also your lesson tomorrow on iReady. Brilliant. Count with me. 1/3.
2/3, 3/3, 4/3, 5/3, 6/3.
6/3, aka 2 wholes. Right?
Why is the denominator 3 if we have 6 spaces?
Ooh, what a good question. Heidi wants to know, why is our denominator 3 if there are 6 spaces on that number line? You don't have any spaces on your number line, Bryson. Get your life together. Do you know? Huh? Let's roll that around in our brain. Let's try another one. Keep that in the back of your head because I've been wondering that too, Heidi. Subtitle. How many 1/3 pieces are in 3 holes? Subtitle, put it right there. I'll write it on the page. And maybe write when I write. Sure. Just a second, subtitle. How many 1/3 pieces are in 3 holes? How many whole bars would we need? Not a trick question. Not a trick question. How many whole bars would we need? Izzy? 3. 3 holes. 3 whole bars. Go ahead and draw 3 whole bars. 1 for me. 1 for myself. 1 for I.
To all for you.
No, me. And myself. And I.
Your name is I now. But none of them.
Mine.
None of those are missing.
Alright, break them up into thirds. We know how to do that. Break them up into thirds, please. Kids, this is the part where you're breaking them up into thirds.
Cutting them apart.
Yes, when I say break, another good way to think about it is like cutting. Once you've done that, count your pieces. Come on, John, get going. Oh, you're counting, sorry. Give me a secret sum when you figured out how many 1/3 pieces are in 1 hole. Oh, sorry, wrong words. How many 1/3 pieces are in 3 holes? Is there a reason we don't have them labeled or counted? We're just playing with our hands. Huxley? 9 what? What are we counting? Be more specific. 9 1/3, aka 9 thirds. Give me 2 signal if you got 9 thirds. So far, so good. We're happy with that. That makes sense. Let's put it on a number line. How many whole numbers do I need on my number line? Madison?
9 1/3 pieces.
Listen to my question.
Or space.
Listen to my question. How many whole numbers? Quickly. I want to know whole numbers, not pieces, whole numbers. Your whole numbers, Madison, are the things we were counting with pretty much until we started playing with fractions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are all whole numbers. How many of those do we need?
9.
No, we do not need 9 of them. Look at your subtitle. 3. I need 3 holes. So my number line is going to go 0 to 3. Again, I find it very helpful if we put those other numbers on there. 1. So far, so good. Yes? Happy?
Yeah.
Great. Now, Heidi asked a really good question earlier. She said, hey, we split that number line into a lot of pieces. But what are we counting by? Look back at our bar model. What size pieces are we counting by? I see a lot more hands than this because you have it in your notebook. You just have to look at it. What am I counting by? Jalen? I'm counting by 1/3. I am counting by thirds. That's what that means. 1/3 and thirds are the same thing. They're synonyms. It might be a third and 1/3. If I added an S, thirds, then yes. One strategy I like to use, Heidi, to help me stay focused is I'm going to take my hand, and you're going to take your hand, and you're going to cover up 2 holes and 3 holes. So the only thing you're looking at is 0 through 1. It's kind of like that iReady game Zoom. You're going to make it zoom in to 0 and 1. Today, John. Yeah, with your hand. Your number line's not even drawn. So between 0 and 1, how many pieces will I need to draw if I'm trying to show how many 1/3 pieces there are? Not a trick question. I have a number line between 0 and 1. How do I put 1/3 or thirds on that number line? Wyatt?
You cut it in the thirds.
Yeah. So far, so good?
Mhm.
All right, move your hands so that now we're only looking at 1 to 2. How many 1/3 pieces go in there?
3.
3. Those are still thirds. Move your hands so you're only looking at 1 hole down here. How many 1/3 pieces go in there? 3. Now, Heidi, that looks like a whole lot more than 3 pieces. Why? I thought we were counting by thirds. Why do I have like a zillion pieces? Use your bar model to help you. I thought we were counting by thirds. Why do I have like a zillion pieces? Bryson, what you thinking?
Because we did 1/3 on each number. Well,
I think I know what you're talking about. So I want to help Bryson out. I think he's on the right track. Alex, what you thinking?
I'm thinking since each 1 whole number has 3/3, we just added all the 3/3 for each 1 whole number.
Oh,
together.
each whole number. Each between 0 and 1, that's a whole number. 1 and 2, that's a whole number. 2 and 3, that's a whole number. Each chunk, this is what I'm talking about when I'm talking about whole numbers. Each chunk is broken into thirds. We just smushed all those chunks together. So are we still counting by thirds?
Yes.
Yes. There's just a whole lot of them. How many of them are there? I should see every single hand because we already read it down. How many thirds are there? I should see every single hand because we already counted it out. If you need to count it again, do that. Macklin?
9.
Yeah, there's 9 1/3 pieces.
Oh, no.
Last one, I promise. How many 1/3 pieces are in 4 holes? Draw your bars. Draw your bars for the page. Alright, you've got your 4 holes drawn. You should have cut those holes into thirds. Not a trick question. Raise your hand. How many 1/3 pieces did you get? Ooh, that's not very many. Keep going. Chuck them up today, Rylan. How many 1/3 pieces are in all 4 of those holes? The answer is not on my pretty face. So if you're just staring at me, hoping a number appears, it's not going to happen. Bryson, make your pieces equal. Because right now you're doing a pretty terrible job at sharing. Ariana, how many pieces did we get? How many? 12 thirds, 12 1/3 pieces, aka 12 thirds. Make your signal if you got 12 thirds. That's what you counted. Count with me. Ready?
1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3.
Perfect. Let's pop it on a number line. Your number line is going to go from 0 to 4, because I've got 4 whole numbers. I'm going to put all those other whole numbers on here. I like to make my holes obvious. That's a hole, that's a hole, that's a hole, that's a hole. That makes it easier for me to say, okay, in this hole, just like up here, I'm going to break it into 3 pieces. So from 0 to 1, 3 pieces. How many pieces between 1 and 2? 3 pieces. Madison, how many pieces between 2 and 3?
9.
Nope. Remember, this chunk right here, between 2 and 3, Madison, is this right here. 3. I just plopped it down. What about between 3 and 4? Izzy? 3. Now, wait a second. I'm counting thirds. There's like 1,000 pieces. I thought I was counting thirds. That don't look like thirds. That looks like 1 billion pieces. Yeah? What's happening?
Because you could keep on going, it doesn't just stop at 1.
What do you mean by that? Why is this not 12s? Because I got 12 pieces, right, Carl?
Mm-hmm.
Uh-huh. And then you need to make yours correctly, because that ain't right. Oh, I see. Why is it not 12s? I got 12 pieces. Evelyn, why is it not 12s?
Because you have 4 holes and each hole you have 3.
Each hole, I have 3 pieces. So I'm still counting by thirds. I just have a bunch of them. Is anyone noticing a pattern? You do not need to write what I haven't read. So way back at the beginning, we figured out one hole had 3 thirds. 2 holes had how many thirds? 6 thirds. How many thirds were in 3 holes? 9 thirds. And then how many how many 1/3 pieces were in 4 holes? 12 thirds. We're noticing a pattern?
Yeah.
I want you to talk to someone at your table, tell them the pattern you're noticing, and what do you think is happening? Why is that pattern happening?
Can you explain what you mean? It's happening
What part of it?
Wait, what about 3-6? I mean, yeah, it's fine. Wait, I thought the pattern also. So if you get a little unique pattern, so even, odd, even, odd, even. Is that a little pattern? It's odd, odd,
2, 1, and a hush fell over the crowd. What are you noticing? We'll start there. I have to sit up. What are you noticing? I see lots of hands because even if you weren't sure what you were noticing, you got a chance to talk to your neighbor. What are you noticing? Carl, what are you noticing?
There's skip counting by 3s.
Let's be a little more specific. What is skip counting by 3s? Someone want to help out Carl? You see some skip counts, but we need to be more specific. What is skip counting by 3s? Heidi?
Fractions.
No, the fractions are not skip counting by 3s. Look alive. Hayden? The numerator is skip counting by 3s. I know it's not the fraction, because what is this fraction worth? What is this fraction worth? What about this one? What about this one? Is that skipping by 3s? Ooh, it's skipping by 1 whole. What else do we notice? Carl and Hayden, I think it was, came up with that the numerator appears to be skip counting by 3s. Evelyn, what did you notice?
I'm not sure if this is correct, but every time you add a whole, I think the 1/3 pieces are getting smaller because when you did 1 whole, there were 3 pieces and they were pretty big.
Sure.
Then when we did 2 wholes, they were a lot smaller. 2 wholes smaller. And when we did 4 wholes, they were really small. They were really small.
Sure. That's mostly because we're writing it on a piece of notebook paper. Right? If I split up a candy bar, 4 candy bars, my 1/3 pieces would be the same size. Because I would have unlimited space. That makes sense. Colby, what you noticing?
That you can, if you're asking how many 1/3 pieces are in 4 holes, you can just say 4 times 3. And whenever that equals how much thirds count.
Say it one more time.
If you're trying to figure out how many 1/3 pieces are in 4 holes, you can just say 4 times 3.
Why does that work? So I'm going to explain to you what Colby just said. Colby said, hey, I'm going to look at this 12/3 right here. And if someone is going to ask me how many thirds are in 4 holes, like I did, Colby's saying I could do 4 times 3. 4 groups of 3. Do you see 4 groups of 3? Look at the board. I see 4 groups of 3. Here's a group. Here's a group. Here's a group. Here's a group. That fraction bar, this piece right here. that has the same power as the division symbol. 12 put into 3 groups equals 4 in each group. You're going to have 4 holes. Tricky. Next blank page. Go ahead and draw that number line. This number line, problem solve. I'm not giving you a new notebook right now, problem solve. This number line goes from 0 to 2. I've put a 1 hole on it. I want you to tell me what fractions go on that number line.
So the final one.
No, it didn't. It trips up 3rd graders all the time. What am I counting by? It'd be helpful if you look at it instead of playing with your notebook. What am I counting by? Because, Carl, I see 4 spaces, don't you? So, am I counting by fourths?
No.
No. Tricky. So tricky. I see 4 spaces. Why am I not counting by fourths then? That's how I figure it out. We count the spaces. Why is it not fourths? It's not fourths. 100% not fourths. But why? Why is it not fourths? Heidi?
Because inside of each hole is like a half. Like 2 halves.
How many holes do I have?
2.
I have a hole here. Do you understand what I say when I say we have a hole?
Yeah.
Like I could draw a bar there. And I have a hole here. I have 2 separate holes. I've just smooshed them together. I got 2 separate pieces. I just smooshed them together. I got 2 separate desks. I just smooshed them together. So far, so good. Now that I know that, zoom. Put your hand on there. Look at just 1 hole. Cover up this half. So you're only looking at 0 to 1. Now that I'm looking at 0 to 1, Madison, how many pieces are there? 2, which tells me I'm counting by what? I'm counting by what? Half. 0 halves, 1 half, 2 half. Switch your zoom. Do you still see 2 pieces? Are we still counting by halves? Let's keep going. From 2 halves, I now have I think it's on this page. I thought it was on this page. Oof. You do not need to draw this number line. You do not need to draw this number line. I just want you to tell me what am I counting by. Halves, thirds, fourths, sixths, eighths, hundredths. What am I counting by? I like that. I see Macklin's trying to count them spaces. That's a good strategy. Just don't count them all. Mason, what are we counting by?
8.
Am I counting by eighths?
No.
Tricky.
No.
Bryson, you got tricked because I know what you did. You just counted all those spaces, right? Except, is that 1 hole?
No.
Look at that number line. I want to know, what am I counting just in 1 hole? 4. Count with me. Ready?
4, 2, 3, 4, 4.
Pause. Does that make sense? Is 1 equal to 4/4? If I was counting by eighths, I would be at 4/8. Is 4/8 equal to 1 whole? No, so there would be a clue. That's not right. Keep going. I'm at 4/4.
5 4,
Mackenzie.
6 4, 7 4, 8 4.
Yeah, it would say 8/8 is 8/8 2.
So you just did instead we didn't do it.
8/8 would be just 1. 8/4 is 2. Colby?
Did you say find it out by saying 2?
No. Well, maybe. As long you got to figure out what you're counting by before you can do that, though. So once you figure out that you're counting by fourths, then you can use that trick. Yeah. What am I counting by? Mackenzie, you should be looking at the screen. What am I counting by? Don't get tricked. Don't get tricked. What am I counting by? Carl? What do we call that? Thirds. Why is it not sixths? Because I see 6 pieces, don't you?
Yes.
Yes? I'm not crazy. There's 6 pieces up there. But why am I not counting by sixths? Evelyn?
Because there are 2 holes in each of them, but that first one, the first one isn't even.
Oh, well, cut me some slack. I'll do the best I can. Imagine. Yeah, fractions deal with 1 whole. I need to know what I'm counting in just 1, and then I can keep counting. This is split up into thirds. I do need, all right. Holy moly. To figure out what we are counting by, this is the part where you're writing. That's called our unit fraction, what we're counting by. You have to figure out how many parts are in 1 whole. Fractions only talk about 1 whole. From there, we just keep going. To figure out what we're counting by, aka we call that our unit fractions. John, you're writing. We have to figure out the parts in 1